Have you ever looked at a complex electrical circuit and wondered if there was an easier way to understand its total behavior? Imagine simplifying a tangled network of components into just one single resistor. This powerful concept allows engineers to quickly analyze and design circuits more effectively. The primary methods for calculating the equivalent resistance of resistors connected in parallel involve using the reciprocal formula, the product over sum formula for two resistors, and a simpler approach for identical resistors. These techniques effectively combine multiple resistive elements into a single equivalent value that simplifies circuit analysis. The fundamental principle behind these calculations stems from the nature of parallel connections. In a parallel circuit, all components share the same voltage across their terminals, while the total current entering the parallel combination divides among the individual branches. Kirchhoff's current law states that the sum of currents entering a node must equal the sum of currents leaving it. Applying Ohm's law to each resistor and combining these relationships leads directly to the reciprocal formula. This formula inherently accounts for how current chooses the path of least resistance, with more current flowing through lower resistance branches. To apply these methods, first identify all the resistors connected in parallel. For any number of parallel resistors, the most general approach is the reciprocal formula, where 1 divided by the equivalent resistance is equal to the sum of the reciprocals of each individual resistance. For example, if you have 3 resistors, say R1, R2, and R3, the formula becomes 1 over R equivalent equals 1 over R1 plus 1 over R2 plus 1 over R3. You then take the reciprocal of that sum to find R equivalent. When dealing with only 2 resistors in parallel, you can use the more convenient product over sum formula, which is R1 times R2 divided by R1 plus R2. Lastly, if you have several identical resistors in parallel, simply divide the value of one resistor by the total number of identical resistors. A useful concept closely related to parallel resistance is conductance, which is the reciprocal of resistance, measured in Siemens. When resistors are in parallel, their conductances simply add up directly. This can often make calculations more intuitive, as you are summing values directly rather than dealing with reciprocals. After summing the individual conductances, you then take the reciprocal of the total conductance to find the equivalent resistance, offering an alternative perspective on the same calculation. Mastering these methods for calculating equivalent parallel resistance is a cornerstone of circuit analysis, allowing you to transform intricate networks into simplified models. This ability is crucial for understanding how current and voltage behave within complex systems, ultimately streamlining the design and troubleshooting of electronic devices and electrical systems.